2012 Civil Engineering question number 33. A concrete beam is prestressed with a parabolic tendon is shown in the sketch. The eccentricity of the tendon is measured from the centroid of cross section. The applied prestressing force at service is 1620 kN. The uniformly distributed load of 45 kN per meter includes the self weight. This is the diagram they have given. This is the side view and this is the cross sectional view. We have to calculate the stress in Newton per mm square in the bottom fiber at mid span is. They have given 4 options. For this question, we can refer to this NPTEL video lecture. Let's try to solve this question. In pre-stress concrete, compressive stress is considered as positive and tensile stress is considered as negative. When the self-weight or the dead load and live load is considered, in soffit of the beam, eccentric load causes compressive stress, the self-weight and the live load causes tensile stress. What he wants to trying to say, if this is the pre-stress beam, this is the center line of the beam, he is saying that in soffit of the beam the eccentric load causes compressive stress. If this is a eccentric load at eccentricity of small e, this will cause compressive stresses in the beam, whereas the self-weight and live load causes the tensile stress, where this dead load will cause tensile stress. That is this tensile stress beam will deflect like this. At the bottom, tensile stresses will generate. At top surface, the compressive stresses will generate. We have this formula for we have this formula for this pre-stress concrete beam in order to calculate the stresses. In top of the beam, eccentric load causes tensile stress. Self-weight and live load causes compressive stress. So the sigma top will become this. We have this formula. Let's first write down what he have given. The width is 500, height is 750 mm, eccentricity is 145 mm, the entire length is 7.3 meter, and the uniformly distributed load of 45 kN per meter, and the applied pre-stressing force as a 1620 kN. So we have all the value. Let's calculate this Z first. Section modulus BD square by 6 for this rectangular cross section. So it will become 500 into 750 square by 6. It will become this much. Moment due to live load and dead load is given by M equals to, for live load and dead load, for uniformly distributed load over the beam will be WL square by 8. Moment at the center will be WL square by 8 maximum moment. So it will become 45 into 7.3 square by 8. It will become around 300 kN. The stress at bottom soffit of the beam is given by, stress at bottom will be P by A plus P into E by Z minus M by Z. So this is the beam, or we can refer this diagram. He is asking stress at bottom soffit. So it's P by A. It's P by A. This P force, P by A plus PE by Z minus MD by Z minus ML by Z. So it will come out to be P, he has given 1620, A is 500. Converting the units, area is 500 into 750. Similarly, the E is 145 mm and Z just now we have calculated. M we have calculated and Z also we have calculated. So stress at soffit will become 2.94 Newton per mm square. A positive sign indicates that the nature of force is compressive. So as per his question, our answer will become compressive stress of 2.94 value, that is 2.9. Thank you.